Hello students. Hello students. Okay. Today's topic is Demoviers Theorem. I think you can all see Demoviers Theorem on the screen. So here you see the first one is Demoviers Theorem. Statement is there for any real number theta and any integer n, cos theta plus I sin theta whole to the power of n is equals to cos n theta plus I sin n theta. That is Demoviers Theorem. And we can also write this cos theta plus I sin theta whole power n as cis theta. We can also write it as cis theta. Then cos theta plus I sin theta whole to the power of negative n is cos n theta minus I sin n theta, where n is an integer. And cos theta plus I sin theta is also be written as 1 by cos theta minus I sin theta. And cos theta minus I sin theta can be written as 1 by cos theta plus I sin theta. Okay, and then cos theta minus I sin theta whole to the power of n is nothing but 1 by cos theta plus I sin theta whole power n. That is nothing but cos theta plus I sin theta whole to the power of minus n. Okay, cis theta times cis pi, that is a cis of theta plus pi, where theta and pi are real numbers. Next, cube roots of unity 1 omega square are called cube roots of unity, where omega is minus 1 plus I times the square root of 3 over 2, and omega square is minus 1 minus I times the square root of 3 over 2. And the relation between 1 omega and omega square, that is 1 plus omega square is equals to 1, right? And then next, very short answers. Question number 1, if A comma B comma C are the angles of a triangle, and x is a cis A and y is a cis B and z is a cis C, find the value of x, y, z, right? So what is x, y, z here? Cis A times cis B times cis C, that is cis of A plus B plus C, which is equals to cos pi plus I sin pi, because of A comma B comma C are the angles of a triangle, right? We know that cos pi plus I sin pi value is minus 1. Next, x is equals to cos theta plus I sin theta. Find x to the power of 6 plus 1 by x to the power of 6. First, let us find x power 6, cos theta plus I sin theta whole to the power of 6. Then we can find out 1 by x power 6, that is nothing but cos 6 theta minus I sin 6 theta. Add up both, you can get the answer. Question number 3, 1 omega square of the cube roots of unity. Then find the value of 1 minus omega plus omega square. First, to simplify 1 minus omega plus omega square. 1 plus omega square is minus omega, so minus omega minus 2 omega whole to the power of 3, that is minus 8. Next, 1 omega square of the cube roots of unity. Then find the value of 1 plus omega whole cube plus of 1 plus omega square whole cube. This is also right, 1 plus omega value and 1 plus omega square value. Then simplify, you can get the answer. Find the cube roots of 8. So cube roots of 8 power 1 over 3, nothing but 8 power 1 over 3 is what? 8 times 1 whole to the power of 1 over 3, which is nothing but 8 power 1 over 3 times 1 power 1 over 3. And 8 power 1 over 3 is nothing but 2 power 3 whole power 1 over 3. Then 2 times 1 power 1 over 3. What is 1 power 1 over 3? It may be 1 or omega square. So 2 omega square are the cube roots of 8. Next, to find the value of 1 plus I square root of 3 whole cube. 1 plus I root 3. First, let us simplify 1 plus I root 3. 1 plus I root 3 is nothing but 2 times cos pi plus I sin pi, that is cis pi by 3. Cis pi by 3 whole to the power of 3, that is cis pi. Yes or no? Cis pi value what? Cis pi value minus 1, I think. And 2 to the power of 3 is 8. 8 times minus 1 is minus 8. Next, 4 marks questions. Cos alpha plus I sin alpha whole to the power of 4 divided by sin beta plus I cos beta whole to the power of 8. So here the numerator is cis alpha and the denominator is not cis beta. Observe clearly, it is not cis beta. So let us multiply this sin beta plus I cos beta with what okay, instead of multiplying, what they are doing, they are writing in place of 1 I square minus I square they are writing. So then if we take I common, cos beta minus I sin beta whole to the power of 8 will come, cos alpha plus I sin alpha whole to the power of 4, and I power 8 cos beta minus I sin beta whole to the power of 8. This is okay, fine. Then cos alpha plus I sin alpha whole to the power of 4, cos beta minus I sin beta whole to the power of minus 8. Then both will come, then both can be written as cis 4 alpha and cis 8 beta. Then cis of 4 alpha plus 8 beta will come. Next one, find the value of 1 minus I whole to the power of 8. So let us take 1 minus I as a plus ib. 1 minus I as a plus ib. Then if we calculate 1 minus 1i value, what we are getting? Square root of 2 we are getting. So 1 minus I whole to the power of 8. 1 minus I whole to the power of 8 is nothing but square root of 2 times 1 minus I by square root of 2 whole power 8. So what is our final answer? Root 2 whole to the power of 8 and root 2 by root 2 1. This is what 1 by root 2 minus I by root 2. Okay, 1 by root 2 is cos 45, 1 by root 2 is sin 45. Then cis of, okay, 8 you can bring inside, then 8 times 45, 8 times 45, cos 360 minus I sin 360, that is 16 times 1 minus 0, that is 16. Right, next question, find the value of root 3 by 2 plus I by 2 whole to the power of 5, root 3 by 2 minus I by 2 whole to the power of 5. Directly we can write, sir, root 3 by 2 cos 30, 1 by 2 sin 30, this is 30, and this is cos 30 minus I sin 30, this is cis of minus 30. Then we can multiply with 5, then we can get cos 150 plus I sin 150 minus of cos 150 minus I sin 150, nothing but 2i times sin 150. Next, 1 omega omega square are the cube roots of unity. Then find the value of 1 minus omega plus omega square whole to the power of 5 and 1 plus omega minus omega square whole to the power of 5. 1 plus omega square value write down and 1 plus omega value write down. Simplify to get the answer. Next, 1 omega omega square are the cube roots of unity. Then prove that 1 by 1 plus 2 omega plus 1 by 2 plus omega is equals to 1 by 1 plus omega. Okay. And 2 minus omega times 2 minus omega square times 2 minus omega power 10 times 2 minus omega power 11 is equals to 49. So let us see the first question. 1 by 1 plus 2 omega plus 1 by 2 plus omega is equals to what? Is equals to 1 by 1 plus 2 omega plus 1 by 2 plus omega minus 1 by 1 plus omega equal to 0. Okay, now let us simplify the left hand side. What is the LCM? 1 plus 2 omega into 2 plus omega. Okay, we can do one thing, sir. First we can here something that done. First we can simplify these two. Then what do we get? 2 plus omega plus 1 plus 2 omega divided by 1 plus 2 omega into 2 plus omega. This one you simplify. Here 1 plus omega is omega square. So 2 times 1 plus omega also omega square. Okay, now understood. 1 plus omega is minus omega square. 2 take out common plus 2 times minus omega square, again minus 2 omega square. And here you multiply these two. If you multiply these two, what do you get? 2 plus omega plus 4 omega plus 2 omega square. Okay, that also if you simplify, I can write here 2 plus omega 4 omega plus 2 omega square. So here 2 omega square is there and 2 is there, right? 4 omega is 2 omega, 2 omega. Then 2 if we take out common, 1 plus omega square, that is 0. Then finally what is left? Here omega and here 2 omega left. From this omega is left and from this 2 omega is left. And this is what? Minus 3 omega square. Minus 3 omega square. Again here minus, once again, this 1 plus omega. 1 plus omega is equals to minus omega. 2 times 1 plus omega minus omega square. Get it or no? Yeah. So minus 3 omega square divided by what we are getting, omega plus 2 omega. Yeah, yes, omega plus 2 omega. This is again minus 3 omega square by 2 omega. Omega omega gets cancelled, minus 3 by 2 times omega. And simplify this part also. Means or you get 1 plus omega square is what, minus omega square. So minus 1 by omega square. Finally we are getting minus 1 by omega square. Right? The denominator 2 from this 2 omega. 2 omega square completely gone here, 2 omega and plus 2. So 2 omega plus omega, 3 omega now. This is 3. 3 gets cancelled. So only minus omega. But both gets cancelled, answer is 0. Okay now? Just omega properties. Next 2 minus omega times 2 minus omega square times 2 minus omega power 10 times 2 minus omega power 11 is equals to 0 is equals to 49 we have to show. So here let us multiply 2 minus omega and 2 minus omega square, and then 2 minus omega power 10 is 2 minus omega and 2 minus omega power 11 is 2 minus omega square. If we multiply them, 2 minus omega times 2 minus omega square whole to the power of 2 will come. So finally we can get 5 plus 2 whole square, that is 49. Clear? Question number 6. 1 comma omega square are the cube roots of unity. Then find the value of, here also same set, cube roots of unity properties we have to apply. 1 minus omega square. This 1 minus omega power 4, again 1 minus omega. 1 minus omega power 8, again 1 minus omega square. Okay now, so every term is repeating 2 times. This is repeating 2 times, this is also repeating 2 times. So 1 minus omega into 1 minus omega square whole power 2. So 1 minus omega and minus omega square plus omega power 3. What we get, this is anyway 1 and omega plus omega square is equals to 1. So 2 plus 1. 9 we are getting finally. Okay. Next, long answer type questions. 1 plus I whole power 2n plus 1 minus I whole power 2n is equals to 2 to the power of n plus 1 cos n pi by 2. So here 1 plus I, 1 minus I first individually, let us simplify them individually, because 1 plus I can be written as root 2 into 1 by root 2 plus I by root 2. Same 1 minus I also, root 2 into 1 by root 2 minus I by root 2. Then we can proceed further. So if we do like that, cos pi by 4 plus I sin pi by 4, then power is 2n now. So cos 2n pi by 4 plus I sin 2n pi by 4, nothing but cos n pi by 4 plus I sin n pi by 4. And then the second also same, in between just minus will come, nothing. And if we add up both the I terms gets cancelled, purely real number will come. 2 power n times 2 times cos n pi by 2, nothing but 2 power n plus 1 into cos n pi by 2. So that is the RHS, right? Next, if n is a positive integer, show that 1 plus I whole power n plus 1 minus I whole power n is equals to, same question, but here power is n. In the previous question power is 2n, here power is n. In the same process we have to do, there is no change. There is no change at all. Okay. Next, question number 3. If alpha comma beta are the roots of the equation x square minus 2x plus 4 equal to 0, then for any n belongs to n, show that alpha power n plus beta power n is equals to 2 power n plus 1 times cos of n pi by 3. Yeah, alpha comma beta are the roots means what, alpha plus beta we can get and alpha beta we can get. Alpha plus beta is 2, alpha beta is 4. And then we can try to find out, okay, if we try to calculate alpha value, exactly what we are getting, 1 plus root 3i, and beta value 1 minus root 3i we are getting. Okay, alpha power n plus beta power n means 1 plus root 3i whole power n, 1 minus root 3i whole power n. Multiply and divide with 2. So 1 by 2 plus root 3 by 2 whole square of n plus 1 by 2 minus root 3 by 2 I whole square of n. Cos pi by 3 plus I sin pi by 3 whole power n plus cos pi by 3 minus I sin pi by 3 whole power n. We can get cos n pi by 3 plus I sin n pi by 3. Yes or no? Right. Next question number 4. Z is equals to cis theta. Then show that z power 2n minus 1 over z power 2n plus 1 is equals to I times tan of n power theta. So if we try to substitute cis theta here, what we are getting cos 2n theta plus I sin 2n theta minus 1 divided by cos 2n theta plus I sin 2n theta plus 1. So trigonometry we have to apply sir here. 1 minus cos 2n theta and 1 plus cos 2n theta formula, like 1 plus cos 2 theta and 1 minus cos 2 theta formula. Then we can get minus 2 sin square theta in the numerator and 2 cos square n theta in the numerator. Yesterday I have told in the same way. So let us take out what is common in the numerator and denominator. Then the remaining terms, after taking 2i sin n theta and 2 cos n theta from the denominator, we are getting cos n theta plus I sin n theta by cos n theta plus I sin n theta. Both gets cancelled. The finally answer 2 gets cancelled. I times sin n theta by cos n theta, that is I times tan of n theta. Next question number 5. If n is an integer, then show that 1 plus cos theta plus I sin theta whole power n plus 1 plus cos theta minus I sin theta whole power of n. Here also same like above question, 1 plus cos 2 theta, 1 minus 1 plus cos 2 theta formula we have to apply. But here these are submultiples. Submultiple formulas we have to apply. 1 plus cos theta, 2 cos square theta by 2. Again in the second also 2 cos square theta by 2. And sin theta is what? Sin theta submultiple formula, 2 sin theta by 2 and cos theta by 2. Okay. Again, what is common that you take out and the remaining simplify. Try to simplify the remaining. I hope imaginary parts gets cancelled. Then the remaining real parts left 2 times cos n theta by 2. Okay, hence LHS is equals to RHS. Question number 6. 1 omega square of the cube root of unity. Then prove that 1 minus omega plus omega square whole power 6. 1 minus omega square plus omega whole power 6. So here you see 1 minus omega plus omega square. 1 plus omega square is minus omega. Minus omega minus omega minus 2 omega. Minus 2 omega whole power 6. 2 power 6 times omega power 6. Omega power 6 is 1. 2 power 6 is what? That is 64. Next 1 plus omega is minus omega square. Minus 2 omega square whole power 6. Minus 2 omega whole power 6 means again 2 power 6 64. And omega power 12 again 1. 64 plus 64 128. The remaining part also we can do it in the same way. Next question number 7. 1 omega square of the cube roots of unity. Then prove that x plus y plus z times x plus y omega plus z omega square times x plus y omega square plus z omega equal to x cube plus y cube plus z cube minus 3xyz. So we know that 1 plus omega square is equals to 0. From that omega plus omega square is equals to minus 1. And omega cube is equals to 1. Omega power 4 is equals to omega. Let us try to see this. X plus y omega plus z omega square times x plus y omega square plus z omega. First we can try to simplify this part. If we multiply, we can get x square and omega times xy plus yz plus zx and xy plus yz plus zx times omega square plus y square plus z square. X square plus y square plus z square, write it once. And from these two, xy plus yz plus zx take out common, omega plus omega square left, that is minus 1. So you are getting x square plus y square plus z square minus xy minus yz minus zx could be multiplied by x plus y plus z, nothing but x cube plus y cube plus z cube minus 3xyz. Right, important question. This is about Demoviers theorem. Okay, Demoviers theorem, complex numbers, theory of equations, probability. Okay, if you try to solve these chapters or if you are perfect in these chapters, you can get almost 70 marks. Okay, what is our today's next topic? PNC, permutations and combinations. Today's next topic is permutations and combinations. nothing, sir. Permutations and combinations also easy because some topics are deleted now. What are the difficult topics are deleted already. The topics what we have that are very easy. So let us try to see once what we have. And here for permutation and combination, permutation is nothing but arrangement, combination is nothing but selection, that we have to remember. So arranging R objects out of n objects in NPR ways, and selecting R objects out of n objects is in NCR ways. And we know the formulas for NPR and NCR. NPR formula is what? N factorial divided by n minus r factorial. Okay. And NCR formula what? N factorial divided by n minus r factorial into r factorial. That is about permutation and combination. Next, the fundamental principle. What is the fundamental principle? If a work can be done in p different ways, then the second work can be done in q different ways. The two works can be done in pq different ways. That is the fundamental theorem. Right. And the sum of, okay, this point also important here. Questions are there based on this. The sum of the all r digit numbers that can be formed using the given n distinct non-zero digits, 1 less than or equals to r less than or equals to n less than or equals to 9 is n minus 1 p r minus 1 times sum of the given digits times 1 1 1 r digits. How many digits are there? That many times we have to write the 1. Okay. Suppose if 0 is one digit among the given n digits, then what we have to do? N minus 1 p r minus 1 sum of the given digits into 1 1 1 r times minus n minus 2 p r minus 2 sum of the given digits times 1 1 1 and so on r minus 1 times. Okay, remember that formula. And here npr can also be written as n minus 1 pr plus n minus 1 pr minus 1. Can I repeat? npr can also be written as n minus 1 pr plus r times n minus 1 pr minus 1. Let us take the RHS n minus 1 pr plus r times n minus 1 pr minus 1. What is n minus 1 pr? N minus 1 factorial divided by n minus r minus 1 factorial plus r times n minus 1 factorial divided by n minus 1 minus of r minus 1 factorial. Minus 1 plus 1 gets cancelled, n minus r factorial is left. N minus r factorial can be written as n minus r into n minus r minus 1 factorial. So n minus r minus 1 factorial, and in from the numerator n minus 1 factorial. If we take out common, what is left? See, what is left? N minus r plus r is left. N minus r plus r means cancel those two. Then we can get n minus 1 factorial times n divided by n minus r factorial. N factorial divided by n minus r factorial, nothing but npr. That's it. Right, let us see the questions. First, short answer questions. Very short answer questions. NP4 is equals to 1680, then find n. In many ways we can do this. Here we use factorization. 1680 factorization, 8 into 7 into 6 into 5. So what is n here? N is 8. Next, NP3 is equals to 1320, then find n. Already in the above question we followed factorization. Here also you can follow the factorization. 10 times 132, that is 12 times 11 times 10. That could be equals to 12. Next, n plus 1 p5 time ratio np6 is equals to 2 to the ratio 7. Find n. Just write the formulas directly. What is n plus 1 p5? N plus 1 factorial divided by n minus 4 factorial, and np6 is n factorial divided by n minus 6 factorial. 2 is to 7. If we simplify that, what do you get? We can get n is equals to 11. Next, question number 4. Find n. If n plus 1 p5 to np5 is 3 is to 2. Same model question like above. Yes or no? Next, question number 5. 56 pr plus 6 to the ratio 54 pr plus 3, 30,800 to 1. Here also directly apply the formulas. 56 factorial divided by 50 minus r factorial into 51 minus r factorial divided by 54 factorial is left. So 54 means 56, 55 left in the numerator, and 51 minus r means 50 minus r left in the denominator. Okay, one point I can tell you here, we have 5 factorial. How do you write this 5 factorial? 5 into 4 factorial means one is reduced, no? One value is reduced. So here 51 minus r factorial is there. That is nothing but 51 minus r into 50 minus r factorial. Already 50 minus r factorial is there in the denominator. That one, this one gets cancelled. 51 minus r is left. So here 30,800 divided by 56 times 55, that is 10. 51 minus r is 10, then r is equals to 40. Clear? Next, 12p5 plus 5 times 12p4 is equals to 13pr. Find r. Better way is directly write the formulas and simplify. Okay, directly 12p5 is what? 12 factorial divided by 12 minus 5 factorial, that is 7 factorial, plus 5 times 12p4, 12 factorial divided by 12 minus 4, how much? 12 minus 4, 8 factorial. Okay, so this is what? 12 factorial divided by 7 factorial is nothing but 1 plus 5 divided by 8. So what it could be? 12 factorial divided by 7 factorial into this is 13 divided by 8, and nothing but 13 factorial by 8 factorial. What is 13 factorial by 8 factorial? 13p5. 13 minus 5 is 8. 13p5. So r is equals to 5. Next, short answer type questions, 4 marks. NP7 is 42 and 42 times NP5. Then find n. In the same way we have to simplify. How we solve the above question just now, problem for practice. In the same way we have to simplify this question number 2 also. Next question. Find the number of ways of permitting the letters of the word picture so that all vowels come together, no two vowels come together. The relative positions of vowels and consonants are not disturbed. Okay, all vowels come together. What is the word here? Picture is the word. Vowels are I, U, V, and the consonants are P, C, T, R. All vowels come together means I, U, E can be taken as a one set, and P, C, T, R are the different sets. Then totally 5 sets we have. 5 sets can be arranged in 5 factorial ways. Okay, and 3 vowels can be arranged internally themselves as 3 factorial ways. So finally the answer is 5 factorial times 3 factorial. Next one. What is the next one? No vowels, no two vowels come together. No two vowels come together. First arrange 4 consonants in 4 factorial ways. Then the remaining places means gaps you can take 1, 2, 3, 4, 5. In 4 gaps, how many vowels we have? 3 vowels we have. Then 5p 3 ways we can. Totally 4 factorial times 5p3, that is 1440. The 3 vowels can be arranged in their relative positions in 3 factorial ways, and 4 consonants can be arranged in their relative positions in 4 factorial ways. 3 vowels can be arranged in their relative positions. Okay. Means in 3 factorial, no? 3 vowels are there. In the 3 places only they can interchange. And 4 consonants can be arranged in their relative positions in 4 factorial ways. Multiply both. Find the number of ways of arranging the letters of the word triangle so that the relative positions of the vowels and consonants are not disturbed. Not disturbed means what? In their same position we have to arrange. First, how many vowels are there? 3 vowels are there. How many consonants are there? 1, 2, 3, 4, 5 consonants are there. Then 3 factorial and 5 factorial. Okay, their relative positions cannot change. Next, question number 4. Find the sum of all 4-digit numbers. Find the sum of all 4-digit numbers that can be formed using the digits 1, 2, 4, 5, 6 without repetition. In the above, we have taken one formula: n minus 1 PR minus 1, sum of the given digits times 1, 1, 1, and so on r times. So here n represents number of digits, r represents what digit number is required. So 5 digits are given, n is equals to 5, 4-digit number is required, 4-digit number is required, r is equals to 4. Then the sum of all 4-digit numbers that can be formed using the digits. Okay, n minus 1 PR minus 1 times the sum of the given digits times 4-digit number, it is 4-digit number, so 4 times 1. Simplify. Next, find the number of ways of arranging 6 boys and 6 girls in a row. In how many of these arrangements all the girls are together, no 2 girls are together, boy and girl come alternatively. 6 boys and 6 girls, all the girls together. Take all the 6 girls as one set and the boys as separate. Then 6 plus 1 7, so totally 7 factorial ways we can arrange them for first question. 7 factorial and the girls internally 6 factorial ways. Next, the second question is no 2 girls are arranged, no 2 girls. So first arrange all the boys, condition on boys is not there, so 6 boys are there in 6 factorial ways we can arrange. Then 7 gaps will be left, in that 7 gaps 6 girls can be filled in 7p6 ways. Okay. Next. And the third one, what is third one? Boy and girl alternative. The row may begin with either a boy or a girl, that is in 2 ways. If it begins with a boy, then odd places will be occupied by boys and even places will be by girls. The 6 boys can be arranged in 6 odd places in 6 factorial ways, and 6 girls in 6 even places by 6 factorial ways. The number of arrangements in which the boys and girls come alternatively is 2 times 6 factorial times 6 factorial. Next, question number 6. Find the number of ways of arranging the 5 boys and 4 girls so that the row begins with a boy and ends with a girl. The number of ways of arranging 5 boys. 1 boy is fixed at the beginning and 1 girl is fixed at the end. Then 4 boys and 3 girls. Totally 7 splits left. That 7 can be arranged. That 7 can be arranged in how many ways? 7 factorial ways. So the total number of required arrangements is 5 boys times 4 girls times 7 factorial. Okay. In another way also we can do here. 1 boy and 1 girl is arranged already. 1, 2, 3, 4, 5, 6, 7. So 7 factorial. First boy may start or second boy may start. Like that, for 5 boys chance is there and for 4 girls chance is there. So 5 times 4. That combinations are 5 2 is 20. The total number of persons. Second question. Okay. Beginning and ending with boy. So first we will fill the first and last places with boys. So 2 places, 5 boys. 5p 2 ways. Remaining 7 places with the remaining 7 persons, 3 boys and 4 girls. That can be in 7 factorial ways. So multiply 4. Next, find the number of ways of arranging 5 different mathematics books, 4 different physics books, and 3 different chemistry books, such that the books of the same subject are together. So 5 is one side, 4 is one side, 3 is one side, totally 4 3 factorial. Internally 5 factorial, internally 4 factorial, internally 3 factorial. And the next problems for practice. Find the number of all. What is that here? Find the number of all 4-letter words that can be formed. Find the number of all 4-letter words that can be formed using the letters of the word equation. How many of these words begin with E, and how many end with N, and how many begin with E and end with N. So equation, in the first position E as fixed. Then remaining number of all 4-letter words. Okay. So in the first position E is fixed. Remaining 3 places are there. 1, 2, 3, 4, 5, 6. 1 second. 1, 2, 3, 4, 5, 6, 7. So here we have 7 letters and 3 places left. In the 3 places we can arrange this as 7 letters. Okay. And next what? How many end with n? How many end with n? How many end with n means at the end n is fixed. Again 3 places left. The 3 places can be filled with remaining 6 letters. And in the beginning E is fixed and the end n is fixed. In the middle 2 places are left. The 2 places can be filled with the remaining 5 letters. Okay. Next, find the sum of all 4-digit numbers that can be formed using the digits. So here 1, 2, 3, 4, 5 are there. So 5 minus 1 P 4 minus 1 into sum of all the digits 0 plus 2 plus 4 plus 7 plus 8 into 1 1 1 1 4 times 1 minus n minus 2 5 minus 2 P r minus 2 4 minus 2 again what 0 plus 2 plus some other 0 plus 2 plus 4 plus 7 plus 8 times 1 1 1 3-digit numbers. Simplify the answer. Next, long answer type questions. If the letters of the word master are permitted in all possible ways and the words are arranged in dictionary order, so rank I think in dictionary order, then find the rank of the word remasked and master. First question is remasked. Remasked letters are A, E, M, R, S, T in dictionary order I have written. So the letters, the words starts with A, 5 factorial. Next the words start with the letter E, 5 factorial. Okay, now what we require R. So with A 5 factorial, with E 5 factorial, with M also 5 factorial. When we get R, we have to stop there. Okay, at R we stop. Again we can move back to A. Again A, with A not required. No, A is not the required letter. So in how many ways? 4 factorial ways. Remaining places can be filled in 4 factorial ways. And next E is required. So E written and again move back. A is not required, then 3 factorial ways. Okay, and E already finished. No, E already finished. Then M is required. M written again moving back. A is required. A written. R is not required for us. R already completed. No, okay. Then S is required. Then T is required. So in 1 factorial way. All could be added. Second one is master. Master also in the same way, sir. Next, if the letters of the word present are permitted in all possible ways and the words thus formed are arranged in dictionary order, find the rank of the word present. Same like above. First take the letters in dictionary order and try to arrange them. Next question number, yeah, that's it about permutations. Next, let us see the combinations. What is combination? Already in the beginning I have told you the combination is nothing but a selection. Right here, example, the combinations formed by taking 2 things at a time from the set A, B, C that are nothing but A, B, A, C, B, C. Okay, A, B, A, C, B, C only, not B, A, not C, A, not C, B. A, B, B, A both are same, no need to take separate. Next, NCR formula here. What is NCR? N factorial by n minus r factorial times r factorial. Why NCR is this? Because in NPR, AB, BA, AC, CA, CB, BC both we can take, but here exactly half of the letters are going. That is the reason we are dividing NPR with r factorial, so that we can get NCR is nothing but n factorial divided by n minus r factorial times r factorial. And these are the values NCN, NC0, NC1. You know all these values already. And when this NCR is equals to NCS is possible if and only if R plus S is equals to N or R is equals to S. Okay. Next, very short answer type question, sir. If NC4 is equals to NC6, then find N. When it is possible, sir, n is equals to either 4 plus 6 or n is equals to s. Next, if 10 times nc2 is equals to 3 times n plus 1 c3, type both the sets formulas and simplify. Question number 3, 12cr plus 1 is equals to 12c3r minus 5. If ncr is equals to ncs, when it is possible? When r is equals to s, r n is equals to r plus s. N is equals to r plus s, we can get r is equals to 4. For for r is equals to s, we can get r is equals to 3. Next, to find n and r. If npr is equals to 1320, ncr is equals to 220. Write both the formulas and simplify. That's it, nothing. Then the next one is nc5 is equals to nc6, n is equals to 11. Next, find the value of 10c5 plus 2 times 10c4 plus 10c3. So substitute the values directly, or else 10c5 plus 10c4. What is 10c5 plus 10c4? It is 11c5, and 10c4 plus 10c3, it is 11c4. 11c5 plus 11c4, it is 12c5. Fine. Next, npr is equals to 5040 and ncr is equals to 210. Right questions. R factorial is equals to npr over ncr, then r is equals to 4. Then find out the n value by taking either npr or ncr. Next, short answer questions. Prove that ncr minus 1 plus ncr is equals to n plus 1 cr. So take the LHS and simplify. ncr minus 1 formula write down and ncr formula write down. What will come out common? That you take out common and the remaining terms you simplify. Automatically you can get the answer. Next one is question number 2. Find the number of ways of selecting 5 books from 9 different mathematics books such that particular book is not included. Take out that particular book. Remaining how many? 8. Okay, from the 8 5 books we have to select 8c5. That's it. Next one. Find the number of ways of selecting 3 vowels and 2 consonants from the letters of the word equation. In this 5 vowels are there, 3 consonants are there. Then the number of selecting 3 vowels out of 5 vowels and 2 consonants out of 3 consonants. Why 3 ways? Why 3 ways? 3 ways. The process is continuous process, so multiplication theorem. 5c3 times 3c2. Find the number of 5-letter words that can be. Find the number of 5-letter words can be formed using 3 consonants and 2 vowels from the letters of the word mixture. Same like above. Next, long answer type questions, 7 marks questions. Prove that 25c4 plus summation r equal to 0 to 4, 29 minus rc minus 3 is equal to 30c4. Take the LHS 25c4. And here 29 minus r is equals to 0, substitute 29c3, then r is equals to 1, substitute 28, then 27, then 26, then 25, last one is 25c5, 25c3, 24c4 and 25c3 is nothing but 26c4 plus 26c3, 27c4 plus 27c3, 28c4 plus 28c3, 29c4 plus 29c3, 30c4. Because the formula, we use this formula, ncr minus 1 plus ncr is equals to n plus 1 cr. Next, question number 2. Yeah, same model. That's it. Concentrate on long answer questions. Our next topic, our next topic is probability, last topic. Probability also, only simple concepts are there, basic concepts are there. Okay, so here what is the meaning of probability? Okay, what they have given, let us see that. If a random experiment results in n exhaustive, mutually exclusive and equally likely elementary events and m of them are favorable to happening of an event E, then the probability of occurrence of E denoted by P of E is equals to P of E is equals to M over N. Okay, I can tell you in simple way, sir. Probability of an event is equals to favorable events divided by total number of events. Remember this one. That's it. Enough. Probability of an event is equals to favorable events divided by total number of events. It's enough. Question number 1. A fair coin is tossed 200 times. Find the probability of getting a head an odd number of times. Okay, 200 times the coin is tossed. Okay, suppose 1 times the coin is tossed, sir. What is the probability of getting head? 1 by 2, right? Here 200 times they are tossing. 200 times they are tossing odd number of times. What is the probability of getting head odd number of times? That means 200. First time we can get head. Third time we can get head. Fifth time we can get head. Like that 199th time also we can get head. Okay, that all we have to add up. That is our favorable event divided by total number of events. 200 times we are tossing a coin. What are the total outcomes? 2 power 200. Next, out of 30 consecutive integers, 2 integers are drawn at random. 30 consecutive integers, 2 integers are drawn at random. Find the probability of their sum. Their sum is odd. So first of all, out of 32, 30 C2. Okay, now the event that the sum of the two integers drawn is odd. Sum of the integers is odd if the out of 2, 1, out of 2, 1 is even, 1 is odd. Sum of two even numbers is even, sum of two odd numbers also even. So when do we get the odd sum? Both should be odd. Out of 15 odd numbers, both should not be even, both should not be odd. One should be even, one should be odd. 15 even numbers are there, one number we have to select in 15 even ways, and 15 odd numbers are there, one should be selected in 15 even ways. So 15 and 15, 225. Favorable outcomes are 225, and the total number of outcomes are 15 times 29. Question number 3. Find the probability of throwing a total score of 7 with 2 dice. 2 dice means what? 2 power 6, 6 power 2. 36 total number of possibilities. And then throwing a total score of 7. 7 means 1 6 will come, 2 5 will come, 3 4 will come. That's it, no? So 1 6 2 5 3 4 4 3 5 2 6 1 also. So totally 6 by 36, 1 by 6. A page is opened at random from a book containing 200 pages. What is the probability that the number on the page is a perfect square? In out of 200 pages, in out of 200 numbers, how many perfect squares are there? So 10 square is 100, 14 square is 196. So totally 14 possibilities are there. 14 out of 200. Next, if 4 fair coins are tossed simultaneously, find the probability that 2 heads and 2 tails can appear. Total number 2 power 4, sir, because 4 coins are tossed. Then getting 2 heads and 2 tails appear. 2 heads and 2 tails should appear. 2 heads and 2 tails should appear. That means taking 2 heads and taking 2 tails, all the possibilities we have to write, that all are 4. That all are 4 factorial, no? H T T H T. Totally 6 will come. Yes, 6 will come. So 6 over 16. Find the probability that a non-leap year contains 53 Sundays, 52 Sundays only. Non-leap year 365 days, 52 Sundays finished. 1 day is left. That day should be Sunday. So what is the probability? 1 over 7. The event that is non-leap year. Non-leap year means 364. Yes, no, the probability that 1 day is not a Sunday. Non-leap year, 365 days. So 1 day maybe Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, 6 over 7. Probability axiomatic approach. Okay, axiomatic approach means like this is set theory formulas are there, no? That formulas we can apply here also. P of E greater than or equal to 0 for all E belongs to P of S. P of S is equals to 1, where S is the Shore event. We can call it as power set of set S. And P of E1 union E2 is equals to P of E1 plus P of E2, because here E1 intersection E2 is equals to 5. Both are there is no common elements between E1 and E2. Next, P of phi is equals to 0. P of E complement is equals to 1 minus P of E. If E1 is subset to E2, then P of E2 minus E1 is equals to P of E2 minus P of E1. If E1 is subset to E2, then P of E1 less than or equals to P of E2. Addition theorem, multiplication theorem also important for the exam set 4 marks questions. So what is addition theorem? P of E1 union E2 is equals to P of E1 plus P of E2 minus P of E1 intersection E2. E1 and E2 are any two events. Okay. Then let us take E1 intersection E2 is equals to pi. Then P1 of E1 intersection E2 is equals to 0. So P of E1 union E2 is nothing but P of E1 plus P of E2. Second case, what there is a common, means E1 intersection E2 is not pi. Then P of E1 union E2 is equals to P of E1 union of E1 union E2 minus E1. Okay. So P of E1 union E2 is equals to P of E1 plus P of E2 minus E1. P of E2 minus E1 can be written as P of E2 minus E1 can be written as P of E2 minus of E1 intersection E2. Okay. Then P of E1 plus P of E2 minus of P of E1 intersection E2. That's it. Understood? E2 minus E1. We have to replace E2 minus E1 with E1 intersection. Sorry, E1 minus E2 minus E1. E2 minus E1 can be written as E2 minus of E1 intersection E2. Next, event A or event B occur. A union B. Both event A and B occur. A intersection B. Neither A nor complement. A occurs but B does not occur. A intersection B complement. Exactly one of the two sets A and B can occur. A intersection B complement union A complement intersection B. Applications of addition theorem on probability. Okay, addition theorem questions given here. A and B are two events, so that P of A minus B is equals to P of A minus P of A intersection B. Okay, that is one probability. Next, the probability that exactly one of them occurs is given by P of A plus P of B minus 2 times P of A intersection B. So first one, A is nothing but A minus B union A intersection B. Then P of A is equals to P of A minus B union of P of A is nothing but P of A minus B union of A intersection B. So A minus B union is plus P of A intersection B. P of A minus B is equals to P of A minus P of A intersection B. Next, the probability that is exactly one of them occurs. P of A minus B union B minus A. P of A minus B plus P of B minus A. P of A minus B is what? P of A minus B is what? P of A minus of P of A intersection B. P of B minus A is what? P of B minus P of A intersection B. P of A plus P of B minus P of A intersection B. Times P of A intersection B. Question number 9. Suppose A and B are the events with P of A, P of B and P of A intersection B. Find the probability that A does not occur. Neither A nor B occur. In the above we have seen the formulas. No, A does not occur. A complement 1 minus P of A. And the probability that neither A nor B occurs. A complement intersection B complement. That is nothing but A and B whole complement. Nothing but 1 minus P of A and B. Next, in an experiment of drawing a card at random from a pack, the event getting the spade is denoted by A and getting a picture card king, queen or jack is denoted by B. Then the probabilities of A comma B, A intersection B, A union B. Right, experiment of drawing a card from the pack 50 to 7. The event of getting a spade, 13 spades will be, so 13 over 52. And B is the event of getting a picture card, 4 will be. Yes or no? 4 kings, 4 queens, 4 jacks, 12 divided by 52. A intersection B is a spade as well as picture, only 4. Only 3 over 52. A union B Okay, maybe king, maybe queen, maybe jack. So 13, p of a is 13 by 12. Okay, p of b, picture card 12 by 52. A intersection b 3 by 52. Simplify that. Next, question number 11. In a class of 60 boys and 20 girls, half of the boys and half of the girls know cricket. Find the probability of the event that a person selected from your class is either a boy or a girl knowing cricket. So totally 60 plus 20, 80 are there. Then 30 boys and 10 girls know the cricket. Selecting a boy. Find the probability of event that a person selected from the class is either a boy or a girl knowing the cricket. Okay, one of the boys select, one of the student is selected. 80 C180. Event that is selected a person is boy. Event that is selected person is a girl knowing the cricket. Interaction is pi. Union is 60 C1 and 60. Half of the boys. Now 30 C1 has to come now. Knowing the cricket, 30 C1 has to come. N of A is 30 C1 and N of B is 10 C1. So P of A is 30 over 80, P of B is 10 over 80. Simplify, then you can get the answer. Here mistake is done, I think. Half of the boys is out of 60, only 30 boys, right? Next, if one ticket is randomly selected, from tickets numbered from 1 to 30, then find the probability that the number on the ticket is multiple of 5 or 7, multiple of 3 or 5. 1 to 30. Multiples of 5 are 7. Multiples of 5, how many? 7. Multiples of 7, how many? 5. Multiples of 3, how many? 10. Multiples of 5, how many? 7. Okay. Then we can do it. N of A6, N of A4, N of C 10. Right. P of A and B, P of A and C have to calculate. Okay. Next, A comma B comma C are 3 newspapers from a city. 20% of the population read A and 16% can read B. A 14% read C, 8% both A and B. Okay, what they given, write everything. 3 newspapers from the city, 20% of the people, 20 by 100, 16 by 100, 14 by 100, 8 by 100, 5 by 100, 4 by 100, 2 by 100. What they given, that we written, and we are writing a formula and we are substituting everything. Then we can get the percentage of the population who read at least one newspaper is 35. The probability for a contractor to get a road contract is 2 by 3 and getting a building contract is 5 by 9. The probability to get at least one contract is 4 by 5. Find the probability that he gets both contracts. A is given, B is given, union is given, intersection will be find out 19 by 45. Question number 15. In a committee of 25 members, each member is proficient either in mathematics or statistics, or in both. 19 of these are proficient in mathematics, 16 statistics, and the probability that a person selected from the committee is proficient in both. A and B is given, A is given, B is given, interaction we have to calculate. A, B, C are 3 horses in a race. Probability of A to win the race is twice the B, and the probability of B is twice that of C. Yeah, write all that. Probability of A 2 times P of A and P of B is 2 times P of C. And finally P of A is equals to 4 times P of C. Some horses, since the horses A, B, C run the race, A union B union C is equals to S, then apply the formula, then we can get P of C is equals to 1 by 7. Then P of A and P of B also we can get. Conditional probability. So conditional event here. Suppose A and B are 2 events of a random experiment. If the event B occurs after the occurrence of event A, then the event happening of B after happening of A is called conditional event, and it is denoted by B by A. Similarly, A by B stands for the event happening of A after the happening of B. Conditional probability. that is conditional event. Conditional probability if A and B are two events in a sample space is P of A not equals to then the probability of B after occurrence of A, P of B over A. P of A over A formula what P of B intersection A divided by P of A. P of A over B formula what P of A intersection B divided by P of B. Okay, let us see the questions. Multiplication theorem also given here. P of A intersection B is equals to P of A times P of B over A. That is nothing but P of B times P of A over B also. Okay, from conditional probability P of B over A is equals to P of B intersection over P of A. P of B intersection is equals to P of A into P of B over A. Right. Next, independent events. Two events A and B are A and B or A and B. Two events A and B of an experiment are called independent if P of A intersection B is equals to P of A times P of B. If A and B are independent, P of B over A is P of B. If A and B are independent, P of A over B is P of A. If A, B, C are independent, P of A intersection B intersection C is equals to P of A into P of A into P of C. A pair of dice is thrown. Find the probability that either of the dice is shown 2 when their sum is 6. A pair of dice is thrown. So 6 power to 36 dice, 36 possibilities. Find the probability that either of the dice shows 2 when their sum is 6. So sum is 6 means 1 5 1 5 5 1 2 4 4 2 3 3. Okay, that all written here. The event sum of the two numbers is 6. The event 2 appears on either of the dice. Next, an urn contains 7 red and 3 black balls. 2 balls are drawn without replacement. What is the probability that the second ball is red if it is known that the first ball is drawn is red? Okay. Total number of balls is 10. The event of the first ball drawn is red. The event that the second ball drawn is red. The first ball drawn is red. The first ball drawn is red. 6C1. N of S is equals to 9C1. P of E2 by P of E1 is equals to N of E2 by N of E1 by N of S 2 by 3. Applications of multiplication theorem. A box contains 4 defective and 6 good bulbs. 2 bulbs are drawn at random without replacement. Find the probability that both the bulbs drawn are good. The event the first bulb is good. The event that the second bulb drawn is good. 6 good bulbs are there. Then 5 good bulbs left. 5C1 is 5. Then P of A, P of B by A is given. Then required event. The event that both the bulbs drawn are good. So P of A is equals to P of A times P of B by A 1 over 3. Next, question number 21. A bag contains 10 identical balls of which 4 are blue, 6 are red and 3 balls are taken out at random from the bag one after the other. Find the probability that all the 3 balls drawn are red. The event that the first ball drawn is red, the event that the second ball drawn is red, the event that the third ball is drawn is red. A of required event is A intersection B intersection C. So N of A calculate, N of B calculate, N of C calculate, N of B by A calculate, then N of C by A intersection B calculate, then P of A intersection B intersection P of A into P of B by A into P of C by A intersection B. Substitute all the values so we can get the answer. Question number 22 also same model. Bag B1 contains 4 white and 2 black balls. Bag B2 contains 3 white and 4 black balls. Event of choosing bag B1, event of choosing bag B2. So both are half possibility. Event is that ball chosen from the selected bag is white. First bag, in that bag white ball we have to select W over V1 and W over E2. Then W intersection E1 union W intersection E2. Applied multiplication theorem. Okay, next question number 23. There are 3 black and 4 white balls in a bag and 4 black and 3 white balls in the second bag. A die is rolled and the first bag is selected. If the die shows up 1 or 3 and the second for the rest, Find the probability of drawing a black ball from the bag thus selected. E1 is given event of selecting first bag, E2 is given as event of selecting second bag. P of E1, P of E2 both corrected. P of E by E1, P of B by E1, drawing the black ball. So in E1 black ball, in E2 also black ball. Yes. But then E1 intersection B union E2 intersection B. Alright. Next, applications of independent events. A and B are independent events. P of A is equals to 0.2, P of B is equals to 0.5. Find the values of P of A by B. P of A by B is P of A because independent events. P of B by A is P of B. P of A intersection B. P of A times P of B. P of A and B. P of A plus P of B minus P of A intersection B. A speaker speaks truth in 75% of the cases and B in 80% of the cases. What is the probability that their statements about the incident do not match? Even the event A speaks, even the event B speaks, and P of E1 is given, P of E2 is given, then P of E1 complement and P of E2 complement. A required event is the event that their statements do not match about the incident. P of E1 intersection E2 complement, union E1 complement to intersection E2. So both simplified and substitute the values. Next, question number 26. A problem in calculus is given to the two students A and B whose chances of solving it is 1 by 3 and 1 by 4. Find the probability of the problem being solved if both of them try independently. So P of A and B is equals to P of A plus P of B minus P of A intersection B. So P of A intersection B is P of A times P of B. Substitute everything. Question number 27. If A and B are independent events, P of A intersection B, P of A times P of B, P of A and B, P of A plus P of B minus P of A intersection B, that is P of A times P of B, and P of B by A, that is P of B, P of A intersection P of A complement intersection B complement, P of A times P of B complement, because independent events. A comma B, C are three events. A comma B comma C are three independent events such that P of A intersection B complement intersection C complement is 1 over 4. P of A complement intersection B complement intersection B intersection C complement is equals to 1 over 8. P of A complement intersection B complement intersection C complement is equals to 1 by 4. Then find P of A comma P of A comma P of C. Okay, P of A is X, P of B is Y, P of C is Z. Okay, and complements and what is given that you write down and simplify. Okay, now important question. Next, 29. If A comma B are two events such that P of A and B is 0.65, P of A and B is 0.15, find the values of P of A complement and P of B complement. P of A complement 1 minus P of A, P of B complement 1 minus P of B. If fair dice is rolled, consider the events A is equals to 1, 3, 5, B is equals to 2, 3, C is equals to 2, 3, 4, 5. P of A and B comma P of A and B. Yeah, everything calculates it. Everything here. What conditional probability is there? Yes. That's it. That's about probability. Concentrate on probability. Okay. Thank you, students.